Hey guys, we are Olewave channel. We are a channel that's focusing on reading the latest speech and NLP publications, including the archived papers. And today, we're going to be reading a paper or the latest archive work. It's called Token Level Sequence Labeling for Spoken Language Understanding using Compositional End-to-End Model by CMU researchers. And if you like our readings, please subscribe our channel and share the videos with your friends. The author, I think they first addressed that nowadays SLU systems are gaining popularity, and usually it could be cascaded approach, which means you first run ASR on the input speech, then you get transcripts, and then you use the transcript and feed them into the subsequent natural language understanding or processing modules. But you can see that they usually suffer from something called error propagation. But any ASR errors, speech recognition error, could be a disaster factor to the subsequent NLU modules, right? And also, they mentioned that this type of system, modality sequence labeling prediction task, causing a divergence, very nice sentence, causing a divergence from its well-established token level tagging formulation. Right? This type of thing push them to think about their proposed method, which is a compositional end-to-end SLU system. And I think I will skip the introduction part because I think I've talked enough amount of it. Let's jump directly to their algorithm. First, they talk about sequence labeling. So the SL does not have any speech recognition involved. So basically, suppose you have a sentence, for example, I like a football. So you're supposed to tag the entity or the property of each word. Maybe the I is subjective, right? Like is something like VP, or football is none, something like this. You just tag I with these. This is called tagging, right? And they're saying that I like football is S, right? Sequence S. And the output or the tagged sequence is Y. Okay. They are of the same length. You see, they're both of length N. And you're supposed to pick up the most likely label sequence as shown in their equation number 1. And then there are different, there are tons of ways of doing this. People have been studying this probably since 30 years ago, at least 20 years ago. And there are some methods which are generative method, which is HMM or maximum likelihood Markov model. I think this is a discriminative model. And definitely, I think the most popular method before the deep learning emerged was the CRF, the discriminative model. I think I can give you a quick comparison between these things. And for the HMM, I think they assume that Y generates the S, right? But given each YL, okay, SL, so they are not they are IID or something called they're conditionally independent of the future and the past. Okay, so this is a very strong assumption, and it's heavily relied on you estimate the probability distribution of the ESL YL correctly. This is HMM, the Markov model. When you go to the maximum entropy Markov model, this is MEMM, okay? And so you see that the generation relation from Y to S no longer exists. So basically all it tries to do is given the whole sequence, whether you can have a estimate of the probability of yi or yl, blah blah blah, yn. But they have this as assumption, which means for the output label YL, it depends on the previous label YL minus 1 and the whole sequence S. Basically, you just try to estimate the probability of YL minus 1 and S given YL minus 1 and S. So this is, you can see, this is a discriminative model. Well, CRF is more, much more straightforward. So you can see it's fairly similar to the maximum entropy model, but it removed the strong assumption of this conditional independence or dependence. Basically, just to try to have S to estimate everything, okay? Everything. So basically, I think it's just as a YL given S. Correct me if I'm wrong, okay? Something like this is very strong assumption. So it means it it doesn't say the YL depends on YL minus 1. It completely rely on S. So I think just to try to estimate this. Maybe I was not very accurate about this, but I think it's like this. Okay, you can see that. And they come up with the equation to estimate the probability of the CRF first. I think this is fairly easy to understand. It's a long thing. I think everybody who does NLP know what the equation number 2 is. You can basically, you have to come up with the function to calculate the Fy of Ys. Okay, then I think in the original paper is calculated like this. But I think this one, yeah, I think they use a linear chain CRF. So again, I'm not an expert on of CRF. It seems that they have similar things like a MEMM. Yeah, so they come up with this equation, and then after they get the equation, they can calculate PY of given S, right? And because people do the deep learning things, and they were able to replace the function or define the function f by using a encoder representation. So you can see it doesn't have the f. Let me zoom out a little bit. I think it's fairly straightforward. You can see this. You can see, compare this equation 6 with the equation 3 is both summations. So they meant this is Fy L minus 1 This is yi minus 1 and the yl. So you can see this equation has 2 parts. The first part is equation 4. You just use an encoder. The encoder can be a transformer model or whatever model you prefer. You can even use a vanilla MLP. That's also called encoder. Okay, you get that embedding. Then this is a transition score. I think it's a fairly. I think you can get the transition score by counting the frequencies of the occurrences. Okay, very straightforward. And then I think I'm not personally a big fan of CRF because it's very sophisticated and it's hard to train by leveraging the parallel algorithm. It cannot be accelerated easily. And then people come up with the token classification model. You can see that instead of using the CRF equation, show the number equation 2, they come up with the equation 7, which says they have a very strong assumption. Basically, they're using the MEMM again. They assume that any output YL is not dependent on its future label or the previous label. That probably makes sense. It's solely dependent on the encoder embedding. Okay, and all you have to do is to multiply all the probabilities to get the overall probability because the IID assumption. Okay. All right. Oh, once we come up with the sequence, finish the sequence labeling in NLP, and then we can move on to the sequence labeling in SLU. SLU means that the input is no longer the text. What is the input? Yes, the input is a voice, speech. So you can see that the input size is no longer the size of n, instead it's the size of t. Usually t is much larger than n. Yeah. So this is also this is a very straightforward equation. Basically, you have the audio in just guess the most likely label sequence y, right? The only difference is that you replace the s with the x each. So there are mainly 2 ways of doing this according to the author. I believe there could be many, but I think here are the 2 main approaches. The first one is a cascade SLU. I think currently it's very popular. It has been mentioned a long time ago, and the people are still using that. You can check the equation. I think you can pause the video and do your homework, and it's fairly simple to deduct it, and you come up with this. But here, I think the author only considers the condition that people only use the top best or one best of the ASR result. This is why he has this thing here, right? Sorry, I don't mean this. This is why he has this equation here. If he use anything like this, show the equation 12, that means that this is the top one best. But like he shown this in his equation, I don't think there's any thing that blocks you from using the summation over all the possible s. S means the ASR transcription, okay? So lots of time people are using unbest ASR results, okay? So you can have multiple hypotheses, okay? So you can go with the equation number 9. You don't have to go equation 10 to 11. Okay? And also, people also, you can see everybody goes to the end-to-end, right? You just fed the speech input in and they give it the labels of the output. You just train them in a whole end-to-end system. So this is shown in equation 13. And don't forget, it uses this IID assumption, okay? Very straightforward. And I think the author mentioned the two common approaches, and then they mentioned their approach. This is what they proposed. But I think this one would also can be categorized into the direct end-to-end SLU. I don't think the author would deny this. Just that they did better work than the previous people. Now let's take a look at their equation again. Yeah, you can see that they are just saying that, okay, I like equation number 9. The equation 14 is, you can see this, right? You can see equations 9 and the equation 14 are exactly the same. So all they want to say is that they want to see or I want to say this, equation 9 can be written in this way if you're using the unbest result. Okay, let me write down the derived equation if you try to use equation, if you want to use unbest results. Okay, what does this say? Unbest results. So it's very simple. It just say S belongs to the unbest results. Unbest results. Unbest. There are only n of S. Okay. Unbest ASR results. This is the derived equation number 9, and well, you can see that in their proposal method, they say, okay, I don't need n different ASR outputs. I just need one. But I think what they meant about S here is not a one-dimensional transcript. S is a tensor, is actually a tensor. It can be a 2D tensor or even can be 3D or multiple dimensions, okay? It's a tensor. But while people weren't using the unbest ASR, S usually is a one-dimensional, one times n tensor. You can call it one-dimensional tensor, okay? This is a 1D tensor. This is unbest. And in their proposed method, that can be either to 2D tensor or even 3D tensor or multiple dimensions, because S is no longer a transcript sequence. Well, in this one, S is a embedding. Embeddings. Okay. So let's take a look at their, what do you call that? Network flow. I think this is my favorite. I think they draw a very, very clear network flow chart. Yeah, hello. So I have to put you on mute because I'm recording this session. But once I finish I would allow you to ask me questions. So you can see that. Where do I start? I would start from first sub ASR net. The color. Okay. ASR subnet. The two nets is another one, the NLU subnet. You can see for the ASR subnet, on the left side, you can see this is a transformer. Transformer, especially transformer decoder. I don't see, seems to me the encoder is also transformer encoder. But the most important thing you want to mention, you want to remember is that this is a cross attention thing happening here. Okay, very, very standard. And then in the decoder, you can see that Y1 ASR got to be here. So that means it use a autoregressive decoder. This is autoregressive decoder. It's a very standard ASR model. So for those of you who are not familiar with transformer, you can search the keyword transformer in my channel. I have a video illustrating the transformer for speech recognition. Okay, then I think the interesting thing is the NLU subnet. So you can see that it also tries to borrow the same architecture as a transformer. The only thing different is that it does not take speech input as an ASR subnet. Instead, it takes two inputs. The first is, you can see, the first input is something goes from the encoder. Okay. Goes all the way to here. Okay. This is similar to the decoder. This is very similar to how the decoder takes input from the speech encoder, right? Same thing. Very similar thing. You can see they call the speech attention because this is not cross attention, because in this part is NLU, it's no longer speech or NLU is alone or ASR alone. So it takes the speech embedding here. So the attention is designed for the encoder in the speech module. Okay. And the next thing is, you can see the flow is the final output from the decoder in the ASR subnet, and it goes all the way into the NLU subnet in it too, right? But you may notice that, okay, here they don't do autoregressive. Why is not autoregressive? Because remember that the author just mentioned that they're using token classification. Let me quickly go back to so you can see that. See the token classification. they have this IID assumption, so no AR is needed. So IID assumption and AR autoregressive assumption are mutually exclusive. And also it's supposed to use, even you use CRF, you can see that they have this type of conditional independence assumption. So you just have to sum over, and it's probably just have this thing related to the previous L-1 label, but the embedding here only is not dependent on the previous label. Let's go back to here. I hope you're with me, but you can see that then you have this embedding here. I would say this is, you can call this encoder of the NLU, right? You see this? I need to zoom out furthermore, so you can see the output from here is shown in equation number 20. So this is H1 over N, and now U. Now use encoder embedding. Okay. Then the next thing is fairly straightforward. You just either plug this into the CRF classifier or token classifier. Fairly straightforward. Then you get a label by label output at a final NLU subnet. Okay. So you can pause the video and take a closer look at this. What do you say? The network flow. You understand better by yourself. Okay. And let you pause the video. Then I will move forward. Okay, I hope you have a better understanding of the network by yourself, so we can move on. So now we move on to the experimental section. I think if you're watch the enough amount of my videos, you would be able to read the experimental section by yourself. And I would just quickly go over things, okay? Because I am not an NLU expert. I even do not know, I've never played with the SLURP or SLU dataset. But you can, just so that you know what they're doing, okay? I think I can do this. First, they try the direct end-to-end SLU. This is also by the same author. They did that probably last year. And the metrics, they're talking about the metrics here. First of all, label F1. Label F1 means that they consider whether you label the non-subjective, objective, the name entity word correctly. I may not be able to say that exactly correct because I'm not an SLU person, but this is just a label accurate, label F1, okay? And then what is SLU F1? That means that the weights, the entity label, and also the word error rates. So that means this is a label F1 plus something like the WER, something like this. Okay, anything like this. Okay, this is a summation of the ASR and SLU error. But I think they're pretty consistent. You can either look at a label F1 or SLU. So from the following, I was just focusing on SLURP's label F1. The cascade SLU. So they use the ASR output and send to the into the NLP section. You got this. And if you do the direct SLU, means they remove the mismatch between these two, and they do not have to propagate the ASR error to get better results that's within the expectation. And then they move on to the compositional as end-to-end SLU. So what's the difference? We might know the difference, okay? It's the first one is the equation number 3, section 3. Let's quickly go back to section 3. It's this. I think it's end-to-end. Direct end-to-end. What's the difference? Let's see. Oh, I think what they meant is for this network, there's no speech attention for her. So all they have to do is just get the ASR embedding. So this time they do not use transcription. Remember, all the these one still use transcription. They use transcription, but from this one already, I think this use ASR. Okay, this one does not use ASR. But this one, any compositional, they use ASR. Compositional end-to-end SLU, they use ASR, but in this way, they only use the embeddings output at the decoder output. Okay, it gets slightly improvement, not that much. So to me, when these guys they use how do you say that? Their way of So I have to say that I'm a little bit confused when they're saying that they're using their model, but with the direct end-to-end formulation. What's different from this one to the direct end-to-end SLU? Maybe I can come back to it later, but I'm pretty clear about the next line, which is with the proposed NLU formulation, which I spent lots of time explaining the network architecture. So when they're using the CRF model to do the prediction, they get about 85.2. When they're using the token classification, I would say there's no much difference between these two. So I would roughly assume these two are the same. And when they're using token classification, because token classification uses a neural network, right? I think CRF also uses the neural network. It's just a last layer. But when they remove the speech attention, you can see the F1 dropped from 85.3 to 84.9. The reason that the system would work worse without speech attention, you can imagine this. I don't have anything to cover on my screen, but you can imagine that suppose the speech attention doesn't go to all the way here. You just use, suppose this speech attention is cut off. Its only use is these SLU encodings as input to the NLU. You can see that the NLU would be only focusing on the content or the high level content. You see that? I'm not a linguistician, but ASR related content. What do I mean by this? So only the NLU would be interested in the words or the textual information that coming from the ASR. But having a input from the speech side or the encoder side, it means more information could be retained, okay, or used. I think one thing Professor Watanabe from CMU, he mentioned that this could be suggesting that he said intonation of the speech may help for NLU and NLU. For example, I would say I like soccer. Right? I like soccer. Or I can say I like soccer. So when I stress the words differently, the meaning of the NLU could be different. But they're doing NER. So it's really hard to tell or to say that whether the intonation has anything to do with the NER. Nobody knows. But according to the numbers, it helps. I mean, the pure speech embedding from the speech encoder does help them to get better F1 scores. Okay. And then they come up with this one. Yeah, there also they mentioned the second table. Table should be above here, okay, on top. Results representing the compatibility of our model with the pre-trained ASR and NLU system. Well, this time they meant that they do not just use the SLURP or SLU datasets ASR, the trained from the SLURP and the SLU dataset. They can use a pre-trained ASR model or pre-trained NER system. For example, if they trained on gazillions amount of data, they can still play on the SLURP, okay? You can see that. Yeah, with NLU fine-tuning, it's called incompatible. I think they also mentioned that. Yeah, I think I didn't read much details. When they're saying that incompatible, I didn't think clearly what do they meant by this, but I'm more familiar with the ASR. That means that, okay, so suppose they try the direct end-to-end SLU, they can just fine-tune the ASR part. I mean, probably can just but that might be some way of just updating the encoders of the ASR or decoders of the ASR. Is that what they meant? Because I think they have to draw a flowchart of the direct end-to-end SLU they talked about, because I have not seen any drawings. The only thing I saw is there's a compositional end-to-end SLU. So all the direct end-to-end SLU, or you might have to see the other publication they talked about. I didn't read it. They might have a flowchart over there. So this is the reason why I couldn't quite understand what they're talking about here. But I can understand the compositional end-to-end SLU with the speech attention. So it's easy to understand. You can just tune on the NLU part. Definitely this time you won't be able to play with the truth to not contain the speech attention. My guess is that the reason why they just play with the NLU that means, I think, Suppose you just fine tune this. So you have these labels and also the input, probably words, right? So now your input is words or word piece, and output is a label, right? So you cannot further backpropagate into the ASR subnet, because you can see, suppose you're using these loops, I think, yeah. With, oh, right. Seems that I slightly understand what they meant about the NLU fine tuning. That probably the incompatible means, so remember that there's probably something between, I think they cannot do this because it's a direct SLU. Direct SLU. They cannot do the NLU fine tuning. Yeah, my gut feeling is that they cannot do this because the NLU fine tuning, like I just mentioned, they have pairs of transcripts and label sequence, right? But the direct end-to-end SLU, the input is voice or speech, and output is a label. There's no way for you to apply this here, okay? But I do not quite understand how they can play with the ASR fine tuning. This is a little bit strange to me. But I think the focus is on the compositional end-to-end SLU. So when they're saying that they can, with the NLU fine tuning, so that means they can use the transcript and labels they got from the NLU task. Look at this again. So they have these, but not the H, okay? Not H. They already got word piece labels or this. So it's fairly difficult for me to understand how they leverage the task related word sequence here. How do they plug into here? Because definitely you can see that this can be used here, right? But then how come this is NLU fine tune? Because this is output. This is the output. Yeah, this is strange to me. But anyways, I can understand. I can understand this with the ASR fine tuning. This is easy to understand. So basically, they have voice and the word sequence. Okay, then they can use the backpropagation to go odd with backpropagation. You backprop the errors all the way to the voice, right? You can see any network on the path of backpropagate would be updated. So you get better, what do you call that? Speech embedding or decoder output to the NLU, right? So you can see after you do this, this is improved, and also this is improved. And then the next is interest. Well, they copy the line again. Or what they mentioned about the with external ASR transcript, they meant they say, so the current ASR model they train in this network is just using the SLRP or SLU data set. Limited amount of data, not a lot of data, but you can definitely use some external better ASR to decode the SLRP test set. Okay, suppose using Hugging Face model, probably way better than the SLRP model itself, trained on SLRP data itself. And then what you can do with this external ASR transcript, what they actually meant, I think, is they run the alignments. What do I mean by running alignment? They do not do train it. Remember, in the fine-tune ASR, you just fine-tune this, right? Using backprop. But they don't do this. So they just do forward loop. You see, this is forward. But because you already know they use the external ASR transcript. External ASR transcript. It's not decoded here. It's decoded by some other ASR somewhere else. They just put it here. Okay. Just no error. They assume that this is 100% correct. And definitely they have during inference, okay, I mean, this is not training. During inference, they have voice. At the voice and the external transcript, you just run alignment, something called alignment. I'm not familiar with whether you know CTC alignment. This is a typical alignment. But you can definitely do the AED alignment, whatever alignment you prefer. It doesn't have to be CTC. Okay. Once you finish the alignment, you know exactly the speech embeddings at here, and also the decoder output at here. So you can see these embeddings are considered to be better than the embedding generated by itself without the external ASR transcript by using the feed forward. So the line that after doing alignment, this embedding got output into the NLU. NLU is not tuned at all. Okay. So this is NLU tuned? I think yeah, I don't think NLU can be tuned. So this is what they meant. And this is very interesting. I think these authors are very smart. By doing this, they don't have to do any fine-tuning step, which means that they don't have to collect, transcribe the development set or training set on the SLU task. Okay. Table 3. I think this is a trivial. I'm going to skip this. Let me see if I could understand this using 2 minutes. Hope you're following with me with NLU fine-tuning. I think maybe the NLU fine-tuning they were talking about. Let's fine-tune here. This is just what I'm thinking, because all these part are heavily related to the speech. This part is still related to the speech, but only this part you could relate it to just an NLU. This is probably they were talking about. Yeah, I think because I'm not an expert in NLP or NLU, I'm trying to learn this. I guess I really didn't understand this, because if you say, I think if you just say you fine-tune an NLU, there's no speech embedding involved. You have to look at the section 2. But section 2, they use the S as input. That I understand. It could be transcription or the word sequence. But they're saying that they're doing the NLU fine-tuning and the sequence labeling in SLU. And you can see the equation here, especially the compositional equation. I think maybe this one and this one. What something I can guess is that although in their equation number 15, they are using an embedding other than transcript, but the transcript can definitely be converted into a embedding by just padding zeros. Okay, for instance, so this is probably, like I say, this is their unlabels, their unlabels, but this is the classes of the labels. So all you have to do is with unlabels, for the first one, you just put a 1 here and then fill the other thing with a 0. And for this one, probably this one is 1, the other one are zeros. You get me? So the rest are the same. So then you can go from a transcript to embeddings. Then you can, when they're talking about the fine-tuning the NLU, so they can tune this part. Okay, even you give it a transcription, they can, using an embedding, serve this as an input. Let's see this. So this one is what do you call that? Zero added word sequence. Okay, and then you can, they definitely can do the backprop from here to here. Okay, so you can see that only the NLU subnet will be updated by this type of called NLU fine-tuning. Okay, I think I understand it correctly, because I think I understood it. Let me go back to here. Yeah, something I don't understand why they saying that the NLU fine-tuning. All right, I think I'm gonna stop here. I wish you enjoyed the thinking process going together with me. And if you like our channel, please subscribe and share your video with your friend. See you next time.